are listening to another episode of the Future Money podcast, presented by the Interledger Foundation, where we invite people of all backgrounds and disciplines to imagine what a financially inclusive future might be. I'm Nawil Karama, and today our newest host, Sabine Schaller, will interview two very special guests.
In this episode, I am in conversation with the creators of the Interledger Protocol, Stefan Thomas and Evan Schwartz.
Their conversation covers a variety of topics and reflection. We dive into their early days and the challenges they faced in creating a universal payment system and the role of ILP in enhancing efficiency. They dive into smart contracts, decentralization, and the need for a universal payment network that connects different ledgers. The conversation highlights the successes and the mistakes made along the way, and of course the ongoing work to improve and integrate technologies. We hope you enjoy another episode of the Future Money podcast.
Welcome to the Future of Money podcast. Today we have two guests with us. We have Stefan Thomas and we have Evan Schwartz, the co-creators of the Interledger Protocol. And for the very little chance that people haven't heard about you ever before, do you maybe want to introduce yourself real quick and tell us a little bit about yourself?
Yeah, my name's Stefan Thomas. I kind of grew up loving writing code and worked as a freelancer, a web developer for a long time. And then I got into Bitcoin back in 2010 and got really fascinated by the idea of, you could write code that moves money around. And that has been my obsession ever since. I think the thing that got me very excited about Bitcoin at the beginning was the idea that you could send money to people internationally very easily. As a freelancer, I knew that there was a lot of friction there. Working with people in other countries was always very difficult, just getting them paid and getting the money there. So Bitcoin didn't fully live up to that by itself. I think it's a great foundation, but I ended up joining Ripple, working on XRP Ledger, working on other blockchain technologies as the chief technology officer at Ripple. And as part of that, also created a research team, which Evan was a part of, and he'll tell you his perspective on that. And yeah, during that time, researching things and trying to figure out what are some of the missing ingredients to take blockchain technology and other existing financial technology and kind of bring it up to the level that we'd like to see, where everything feels really frictionless. That led to the development of Interledger. And so nowadays I am the chairperson of the Interledger Foundation, and I kind of work full-time on open source code. I work on a project called Dassi, which we'll probably get into later, and just trying to get Interledger out there into the world.
And my name's Evan Schwartz. I've worked as a software engineer for the past 10 plus years. Worked on a couple of different open source projects in general, like open source things. I always wanted to be an inventor, and that's kind of the thing I love doing. So coming up with new ideas for things. That included working with Stefan on Interledger and some other things after that.
So Evan, I know you guys met at Ripple. Did you have any other prior experience with payments and financial products, stuff like that? Or how did you end up in that space?
I had no prior experience whatsoever. I was just out of college and looking for jobs, and got introduced to Ripple. To be honest, was not particularly interested, but was I need interview practice, and so I'll take the interview anyway. And then read up on it, seemed kind of interesting, and then met up with Stefan for an in-person interview. We ended up talking for an hour and a half, and I was like, wow, this seems crazy. This is like a 14-person company talking about connecting the global financial system more. That seems nuts, but also very interesting. And that was kind of how we started working together.
This is a long time ago now. What was your knowledge about blockchain at the time? Were you interested in it at all, or didn't care?
No, I didn't know anything about it. I had never heard of it before being put in touch with you, and had no particular interest, and was just like, okay, let me find out about this. And then your interview style at the time was just explaining Ripple's technology, and then I think judging people based on the questions that they were asking. And I didn't know anything, so I was very happy to just ask lots of questions, and that worked out well.
Yeah, I was like, lock the door. This person's not leaving.
But Interledger wasn't something that you already had in your mind at that time, Stefan? Or
I think maybe the sort of seeds were in the lack of scalability in existing ledgers. Like I already knew that we're going to need something, because if you think about how a blockchain works, you have a ledger and it's sort of distributed across lots of different computers all over the world. But every transaction that happens has to be recorded by all of those computers. And so as more and more people try to transact, eventually the math just doesn't math. And, you're just doing too much work for each transaction. And so, in the traditional finance world, the traditional payments world, the way that you often deal with that scalability issue is with netting. So like if you make a credit card transaction, there isn't like an international bank wire that one-to-one corresponds to your credit card transaction, right? Like the way that works is that the banks will add up all the transactions and then send one big transfer to net it all up. And so I always thought it would be something like that happening for these newer technologies as well. I just didn't know exactly what it would look like.
I think the other kernel of an idea that contributed to it a lot was when I joined Ripple, the company's whole mission was about connecting the global financial system more. And the idea was like, if you can get everyone onto one ledger that supports multiple currencies and atomic transactions between them, then you could have global interoperability. And that idea, I think, was kind of in the zeitgeist at the time to some extent, though maybe a little bit before its time. And I remember at some point, Stefan saying, I don't know if it's going to be possible to get everyone on one ledger, because like there was Bitcoin sort of started off the whole blockchain thing, but then a lot of other people came out with different blockchains with slightly different features. And I think like one of the things that I always give a lot of credit to Stefan for was like the company's whole mission was like, let's connect the entire world's financial system. Let's connect everybody to this one ledger. And I think the way that I remember Stefan looking at it was like, what if that's not possible? Is there a way to achieve this vision in a different way? And I think that was one of the kernels that kind of kicked off what became the Interledger project.
I remember having a lot of anxiety about sharing that thought with my colleagues. Like the very first person I told was Monica Long, who was at the time our head of communications. And I basically just like took her into a meeting room and I was like, so this is going to sound a little weird because, our whole thing is that we want everybody to connect through the XRP ledger, but what if there were multiple ledgers and we had to think about how to connect them all together? And like, what if we changed our view and the XRP ledger is just one of many, many ledgers? And that seemed initially very like counter to the company's goals and took us a long time to kind of figure out how it all fits together. But I think looking back, even with the original vision, you still have to deal with legacy ledgers. You still have to deal with bank internal ledgers and companies' internal ledgers. So the world has many, many ledgers and you need a way to get across them. So that was sort of inevitable, but yeah, it was very scary at the beginning.
We've already talked a little bit about blockchain inspiring it, but it not being the greatest solution. So you came up with Interledger. For the more non-technical audience, can you briefly describe how Interledger works? And I know this is a challenge, but I have full confidence since you pitched it at Ripple that you will be able to do that.
Well, who are you asking? Are you asking me? Are you asking him? Because I think you might get slightly different explanation.
I'm asking Evan this time.
All right. Interledger is about routing money across different payment networks. So there's lots of different payment networks in the world. And the idea is to come up with a really, really simple way of sending money across them so that you and I could be on different payment networks and still send money to one another. I think that's the simplest way that I can put it. It's also worth adding that in thinking about the design for how to actually do that, we took a lot of inspiration from the design of the internet, which is also why the names are somewhat similar. But the internet is also about routing packets of data, not money, across independent networks. So I'm on a different internet service provider than you guys are, and that's fine because the internet just makes the connection happen in the background. And that's kind of the hope with Interledger, is that we could be on completely different payment providers and still be able to send money between one another.
Yeah, I mean, like we could talk for hours on different ways to explain Interledger. I'd say maybe a couple of thoughts. Like one, if we're just talking about what's the goal of Interledger, that's like one side of it, right? Which is, I would say, just making money move very efficiently. And getting to a point where, communication has become so ingrained and effortless. You don't think about like, oh, I'm going to have to write a letter and I'm going to have to take it to the post office. Like you just type whatever you want to send to somebody and you send it, and within seconds they can read it. And we haven't quite reached that level yet with payments, even though they're also just bits and bytes. And so Interledger is essentially trying to catch payments up to the same level that data is at. So that's one side of it. And then when you talk about the technology, I think Evan kind of already covered, like it's very much inspired by some of the key ideas behind the internet. One of them I would highlight is this idea of just it being an abstraction layer. It's just an API. Like you are building applications for Interledger, and you don't know if they're eventually going to run on some blockchain, or if they're going to run on some bank ledger, or they're going to run on some other system. It doesn't matter. You're programming your application for Interledger, and that means it's going to run everywhere. So it's kind of like connecting all the different solutions together. And then I think the other thing, which is maybe getting a little too into the weeds at this stage of the conversation, but I'll mention it briefly, which is the end-to-end principle. So the internet kind of was competing at the time when it was being developed with lots of other network interoperability standards, because people realized, okay, we have all these networks, but kind of would be nice if they were all connected together. So there were a bunch of different efforts along those lines. But I think one thing that really helped the internet win and become the standard that we all use today was that it was able to be much more simple. And the reason it was able to be much more simple is because it realized that there are a lot of features that you can provide on the network level, like reliability, checksums, all sorts of things like that. But if you actually skip all of those and you make a deliberately unreliable core network, that core network ends up being very simple. And then what you do is you treat all those issues, or you handle all those issues at the endpoints. So when I send a packet over the internet, I don't know if it's going to get there. Maybe not. Maybe it will. Maybe it won't. Maybe it'll take a while. Maybe it'll get there tomorrow. Like, I don't know. But I will handle those different failure modes. And you kind of have to do that anyway, because whatever reliability mechanism you implement on the network layer could fail. And so you don't really lose anything by doing it this way, but you gain a lot of simplicity, or like you lose a lot of complexity in that sense, right? So we tried to take that same architectural approach with Interledger. And if anything, first of all, credit to Evan, because he was the first one to kind of think in that direction. And that ended up being, I would say, the key breakthrough is like really using the internet as the foundation for the design. And we've been surprised again and again how well it actually translates over. Like there've been so many things where it's like, surely payments are different, money is different in this way or that way. And it ended up being like, no, actually we can just do what the internet does, So it was very interesting.
We are on version 4 of the Interledger protocol right now, and I'm assuming we made it simpler from 1 to 4. Is that correct?
Yes, I would say much simpler.
Can we make it even simpler? Do you have ideas?
There are actually a few things I am thinking about. I don't know if we should talk about this here, but it's kind of interesting because like the internet went through its own sort of revision with IPv4 to IPv6. So for those who don't know or follow network technology, IPv4 was the original version of the internet that ended up being popular. I think a lot of internet traffic, I don't know what the numbers are, but probably the majority of internet traffic is still using IPv4 today. But there was sort of one big issue with IPv4 was that it was meant as a sort of a testing version. It wasn't really meant to be the thing that then takes off because it had a limited address space. And when I say limited, it's like 4 billion, a little over 4 billion addresses. So it's not that limited. But when you're trying to connect the whole world, like it does start to become an issue. And with the number of devices that are trying to connect today, it's definitely become a bottleneck. And so that was the main driving force. But of course, when you're doing a revision to the core protocols, you try to make some other improvements. You cut some stuff you didn't end up needing. You add some stuff that was missing. And so there's a new version of the internet protocol called IPv6. And people are trying to roll it out and have been for many decades, several decades. And we're sort of in a similar spot, I think, where like, there is IPv4, it works great, it has all the things you need, but we are always thinking about like, what are some tweaks we could do, some things we could clean up. I think one thing that is sort of a mistake that I pushed for at the time was The date format in the Interledger packet is sort of a textual format. I'm not going to go through all the reasons why I thought that was a good idea, but I think like today, even when I'm writing my own implementations of it, I'm like, I wish it just a number. Just like a lot of network protocols do just use an integer. So kind of wish it was that. There is a congestion control mechanism in the Internet Protocol called explicit congestion notification, CN. Again, it could get very technical here, but basically it allows the network to detect when congestion is about to happen without actually having to drop any packets. So it increases efficiency. The internet was able to implement it because they had some bits available that they could sneak in and make these the ECN bits. We don't really have any spot for that in the Interledger protocol format. So yeah, we might make some tweaks and stuff. That's actually one of the conversations I'm very excited to have at the summit in Cape Town later this year.
Likewise. Evan, do you have ideas?
No, I think it's good as is. No, and in all seriousness, I mean, the approach that we took with the different versions was we had this idea, like, we don't know what the final version will look like, but we'll know it when we see it. And I very distinctly remember when we had that feeling, and it sort of gave us all goosebumps at the time because we had spent so much time poring over, like, how much can we remove? Do we really need this aspect? And we had a couple of different protocols that were part of what we called ILP at the time. We had a couple more fields in the packet. We debated, do we need a packet format? I was the proponent of not, until convinced that it was a better idea to have a specific format. And we like really poured over every aspect of it to try to see, is there anything we can rip out of here? And when we got to what we considered at the time the final version, or I think still sort of do, or I still do, let's say, we had that feeling of there's nothing left to take out. For the thing that Stefan mentioned, I would be curious whether like that extra bit would be possible to add in a non-breaking way, so that like maybe there's a version 4.1, but ideally not a 5, or not a 5 for a long time. Because I think there's a lot of value in maintaining interoperability and not making breaking changes.
Yeah, I definitely agree with that. I think for protocol designers, it's always very tempting to make breaking changes because you always see the next shiny object. But especially when you're trying to get the new protocols off the ground, yeah, that can be a big problem if you constantly kill the momentum.
I'm not going to lie, I am a fan of that current version as is. But I mean, there's the Interledger protocol itself, but then there's also the Interledger stack. So we have multiple protocols that all together define kind of what Interledger is. And you design all of them. So maybe this one is for Evan. What's your favorite one in there? What do you think is the most rounded?
Definitely ILP itself. So the idea of the stack is similar to the internet. There's different layers of the internet stack. Different people draw the lines in different places, but roughly you have networking, which on the internet, that's technologies like Ethernet. You have internetworking, which is the internet protocol. And that the only job of the internet protocol is just saying, I have this packet of data, can you get it over there? And it defines what over there means, but it doesn't tell you anything about how to get over there, how fast you need to get it there, it's just like a way of saying over there. And then on top of that, you build all of the reliability stuff that Stefan had mentioned. All of the web and all of those technologies are higher level. And the whole idea with the end-to-end principle that Stefan mentioned is that by trying to simplify the core as much as possible, you make it so that we don't really have to agree on that much across the entire thing. And that allows it to evolve on the higher levels and the lower levels. So the technologies that the internet was built on have changed many, many times. And there's been a lot of innovation on the networking layer. And there's also been new protocols that have been built on top of it. And that's one of the things that's really, really cool. Interledger tries to take that same approach. So we can have new ledger technologies that it's built on, and then new application protocols that are built on top of it. But the idea is that the Interledger protocol should stay the same, because it's just trying to define, can you get this money over there? And similar to the internet, it's defining how you address things and how you say over there, but not saying how you get there or anything like that.
Well, I'll have a different answer because I just worked on a re-implementation of the stream protocol. So we're talking about the end-to-end principle, trying to get all that complexity out of the ILP, the Interledger Protocol, and then moving it one layer up. Well, that layer up is the stream protocol. And so I think a lot of the credit for why Interledger is so simple actually belongs to the stream protocol, because that's what's allowing Interledger to be more simple. And, Evan was the one who developed a lot of stream and designed it and implemented it. And I hadn't even really looked at the implementation back then. And so over the last couple of months when I was re-implementing it, just to kind of learn it better, I really got a much deeper appreciation for all the thought and design that went into it. So my answer would be the stream protocol. I love it. It's really cool.
Well, I will repass that credit on to the Quick protocol designers, because Quick is a newer version, kind of replacement of TCP, which is a kind of an important protocol on the internet. And Quick is a newer version that adds a lot more fancy features. And that's based on a lot of years of people using TCP and finding all the problems with it. And so Quick was a really well-designed protocol. And we were kind of like, okay, great. If we want to design a transport layer protocol for Interledger, can we take inspiration not from the original version of the internet's transport protocol, but also from what they learned in the subsequent decades? And so a lot of the time spent developing Stream was basically like, I had the RFC for Quick open in one tab, and then a parallel one was like writing, okay, that seems relevant for us too. Great, let's copy that idea. Oh, great. And that was a great jumping off point to build that protocol. So most of that credit belongs to the Quick authors.
Stefan, you've mentioned Dassi now twice. You've mentioned it early on, and now you said you've been working on a re-implementation. Do you want to tell us a bit more about Dassi and what your goal is with Dassi?
Yeah, I would say that it's interesting to think that we've been working on this now for 10 years, or a little over 10 years. And if you'd asked me like where are we going to be in 10 years, like 10 years ago, I probably would have said that the adoption would be further along than it is, right? And so I think that, I will say that I personally made a lot of mistakes in terms of like the strategies to pursue and how to drive adoption and some of the decisions along the way. But thankfully, those are all, transitory, right? Like you make a mistake in the strategy for adoption, you learn from it, you try a different approach. The parts I'm much more happy with is how the actual protocols are designed and everything. But in the vein of like what's a better strategy, the best success that we've had with Interledger were probably in 2019 when we had sort of a community network built around Codius and Interledger, and people could run their own Interledger nodes and things like that. And I remember that time as being very dynamic. Like this was the time where somebody made a dashboard for seeing the status of the Codius network that we had no idea this was coming. We don't know, I think we still don't know who built it, or just, I don't. And it just sort of popped up and it was amazing. And I really regret that at the time we sort of said like, okay, we have to move towards like more regulated institutions and working with these like, traditional financial institutions. And so the community network kind of needs to take a step back, and we stopped supporting it, and we kind of actively discouraged people from doing that. And I think that was a huge mistake, because for a community to grow and thrive, like people need to be able to actually do something and participate and so on. And so I wanted to bring some of that spirit back to the project. And, we are living in these amazing times where there are all these blockchains, and you can just write some code and it'll connect up and you generate a private key. And so suddenly you can send money around. And so I was very interested in bringing that feeling back. Dassi is a peer-to-peer implementation of Interledger. So rather than being meant to be run by centralized organizations, it's sort of something that you just download, you run it, and it does stuff. It does Interledger stuff. It speaks all the Interledger protocols from the bottom of the stack all the way up to Stream. And even open payments, which we haven't mentioned yet, but that's sort of how to negotiate a payment, like how much should I pay, that sort of thing. And it's my hope that people will try it out and play around with it and learn about Interledger that way, and hopefully drive the adoption forward.
Hey there, listeners. You're tuned into the Future Money podcast, where we explore everything related to digital financial inclusion. I'm Aisha Ware, Program Manager at the Interledger Foundation, and we've got something exciting for you. But before we dive back into the episode, I wanted to share a project I was involved in collaboration with Carolyn Malachi and students at Howard University Audio Advanced Production course. The course is a capstone for seniors in the audio sequence. It is designed to challenge students to develop long-form audio productions, including podcasts, audiobooks, film scores, and more. Through this project, students created interstitials about Interledger for our Future Money podcast. Here is a sample from Shamari Hall, a 2023 graduate of Howard University. Stay tuned.
Welcome to the Interledger Summit. Join us as we bring together innovators, regulators, and advocates for financial inclusion to shape the future of digital financial services. Hear from change makers, problem solvers, and visionaries who are working to create a more equitable and connected world through Interledger. Don't miss the chance to network, discuss ideas, and to be a part of a movement that's transforming financial services for everyone. Visit interledger.org/summit to learn more and explore how digital finance can benefit everyone, everywhere.
Thanks for listening to Shamari's sample. We hope you enjoyed the rest of the episode with Stefan Thomas and Evan Schwartz.
Well, now that you've mentioned Codius, I have to ask you to explain Codius to the audience.
Well, Codius is an interesting one because in some ways it's the sort of missing link between the blockchain era and like when we were working on blockchain a lot and the Interledger era. Basically, I was very interested in smart contracts. I helped start the Swiss meetup group for Bitcoin, which was one of the groups that like really dove deep on smart contracts. When I was working for Ripple early on, I was working on general purpose smart contracts. So Bitcoin had this sort of very minimal stack-based scripting language built in. And so we were thinking about like, what would it look like if you built like a general purpose programming language into a blockchain? And, somebody who was crashing on my couch at the time was Vitalik. So he clearly got somewhat inspired by that work. And so, that sort of evolved over time. And I think I got to a point where I was like, okay, why are we even trying to build all the logic into the blockchain itself anyway? Like a blockchain is this sort of thing where, as I mentioned at the beginning, you're running everything many, many times. And so it's very computationally expensive already. So why are you doing all of your logic on that layer? The way we do it in most software architecture is we have a database and then we have our business logic separate from that. You have a separate layer for that. And so, we started to think about like, okay, this was Evan and I back in the day as well, thinking about like, okay, so we have the blockchain, which is kind of our data layer. Well, what would a decentralized business logic layer look like? And that became the Codius project. And the basic idea is just, okay, you have these stateless systems, so they are not databases. And all they do is they run your code, but you can have many of them. And they then might make transactions against the blockchain. They might query some traditional API, et cetera. It's actually kind of a pretty simple idea. You just have this like group of nodes that does stuff for you. And that way you implement smart contracts in a more flexible way. But the problem we ran into very quickly was, okay, so we have this very neutral smart contracts layer, the smart contracts layer that's not tied to any particular blockchain. You could use it with any blockchain. You could use it across blockchains. You could use it across non-blockchain systems. But you kind of have to pay these hosts that are running that code for you. And you could pay them with a credit card or something like that, but that seems very clunky. Like you're trying to pay 100 different hosts with 100 different credit card payments of 12 cents. Like that seems very inefficient. And so I think that was partly what prompted the need for the efficiency that Interledger brings to the table. So I think Codius has always been this sort of idea that everyone's still very interested in. It still seems like a very good idea, but it's taken a bit of a back seat compared to Interledger because Interledger seems like the thing that you need to enable it. Currently, there is a bit of work going on Codius here at Coil. We haven't shut down entirely. We've, spun down quite a lot, but we still have some things going on. And one of those things is a new version of Codius. So I don't want to say too much yet because it obviously still very early days.
Very exciting. Codius is what got me hooked on Interledger. Evan, any other project going on around Interledger early on that I don't know about? Is there anything else that you experimented with?
I think one of the coolest parts about Interledger is that neutrality point, which is kind of what Stefan was mentioning is like why you need something like that for Codius. He mentioned the efficiency. I think the other important point is the neutrality. Like you're not picking one blockchain, which, then all the initial people that got in on that early get super rich, and you're not picking like one company's technology. You're picking kind of a more neutral standard. And so like one of the toy experiments that I had done back in the day was like integrating it with torrenting, with the idea that torrents are an efficient way of downloading media files and other types of files. But the two problems with it is you have both an unfairness about like the actual torrent network, but then also the content creators don't get paid, which is why it's historically been associated with piracy. And with something like Interledger, you could actually have the original content creators get paid along with the people that are helping torrent. And so that was something that we had played with as well, which relies on that neutrality and the currency agnosticism. That was another example of something that we played with.
Yeah, it's actually really interesting hearing you talk about torrenting, because it sort of reminds me about like how the world has moved in a certain direction. Like, so many of the ways that we interact with digital services today is very, very centralized. You have these gigantic companies, they have gigantic social media networks. I don't have to list all the names, but the usual suspects. And, when Evan and when we were growing up, like, there was the web, there were lots of the separate websites, and obviously that still exists. It's just really outshined at the moment by these very large hubs that sort of have taken over the mass of internet use. And it's kind of interesting that is happening at the same time as some of these decentralization technologies, making progress. And there's so many projects like Blue Sky and Nostr and Mastodon, all these different things that are trying to distribute these. And I really wonder, like, what is the missing piece that really makes it flip over and makes those services more attractive than the very centralized ones. And I think one of the things that you can certainly speculate might be part of that is the ability to create business models. Because like if I can, be on one social media network where I get paid ad revenue and I can make money, but then I'm on a decentralized version of that, but I don't get any ad revenue, I don't get any money, then obviously I'm going to go with the mainstream thing that pays me, right? And so I always wanted there to be like an alternative where you could make a living by creating content, by publishing content, but still not be below one of these, centralized platforms or be beholden to one of these centralized platforms. And I think that's still very much like people are looking for that solution. It's just nobody has quite got the recipe right. I think for us, like the part that we're focused on as the Interledger community is like, let's make sure Interledger is the best protocol for that. And then when somebody wants to get the recipe right, they reach for Interledger to solve that problem.
Since you mentioned the web and online, so how do you see a universal payments network like Interledger building more equitable opportunities online?
One of the things I always found super exciting and interesting about Interledger is that it's hard to say because I think when the internet was rolling out, it was not obvious how widespread it would become and how ubiquitous it would become. And I think that's sort of the potential, which is both like very interesting and also, to be honest, a little bit scary with something like Interledger, where I think it has the potential to be everywhere in a sense. And the idea of making it such that there's like one universal payment network or internetwork such that anyone can pay anyone for anything, basically, it would make it possible to include that in a lot more places. So Stefan had mentioned the web, and obviously like way more of society and life is being hooked up to the internet, and the payment experience is kind of clunky still. And so that does push towards centralization with services that can hold on to your credit card details and then charge you little amounts every once in a while. So with Interledger, you could have payment experiences that are much more seamless, that are hooked up to a lot more places. So that could be ranging from like paying for transit in different countries to consuming content or any type of business transaction that you do. Instead of this discussion around like, oh, what payment network should we use for this? You just say, here's the money, and then it's done. That's a little bit of a vague answer, but I do think it's a little bit hard to predict how something like that would roll out, or like what kind of applications people would end up with. Because I think a lot of the most exciting applications of the internet were things that probably would have been very difficult to foresee before it started rolling out.
Wow, that's a deep topic. I mean, I started a startup Coil in 2018, which was essentially built around that question. And so I would say that over the years, we've learned a lot in terms of like how the ecosystem of the web actually works. I think one of the things that you would hear a lot, and also that we thought about a lot when going into it, was this idea that like, can we get rid of ads? Because ads seem kind of annoying and they seem kind of a distraction. But the issue is that what ads really do is they sort of solve in a very elegant or seamless way the problem that like you're getting this like small amount of value from consuming content. And there's also a lot of value in companies trying to get their product out there, right? Like you'd say you're an inventor, Evan says he's an inventor and he's invented lots of things. How does he get people to use his inventions, right? Like he's got to market it somewhere. He's got to advertise it somewhere, right? And so that is a very important function to fulfill. And so you can't just get rid of ads. They create a lot of value on both sides, not just in the things that they fund, but also in the things that they market, And so I think that if I had to make a prediction on how something like Interledger could help in the future, is maybe creating a bit more flexibility in terms of maybe I want to consume ads from this source, and then I want to take the money that I made from consuming those ads and then use that to pay for the content that I'm consuming from that source. And it doesn't have to be all linked together, because I think that's where a lot of the friction comes from. You have advertisers that don't want to advertise on YouTube because their beautiful new product is going to be next to a not so nice video. And so then YouTube cracks down on what you can say in your videos. And so then everyone is upset because, their particular community, that type of discourse is okay, but it might not be brand safe. And so then they complain that they're being censored. And so there's like all these different things that create friction when you put the content and the ads very tightly coupled together. Not to mention the centralization that you get, where it's like, if you're a content creator and you get kicked off of YouTube, it's not like there's an equally large long form video sharing website you can go to instead. It's sort of like, you're going to a much smaller platform from there, And so I think that the biggest opportunity is to make it so that there can be lots of little hubs, and they're all kind of working together in the sense that like, if there's one hub over here that has very relevant ads and I really like watching their ads, I can somehow hook that into my client and then go consume the content from over here, and everyone's kind of happy. That's sort of the vision. I think I glossed over a lot of the complexity, so there's still a lot of work to be done before we can see that realized.
And then maybe moving even broader outside of online to the real world. Evan, what do you think? How will Interledger impact individuals or the society in large?
I'm excited about playing around with Dassi some more, and that's not quite the deep discussion, but I think actually going from lots of discussions to being able to just spin it up and use it is quite exciting, because I think, as Stefan was mentioning before, the community kind of needs that dynamism of actually using it and building things and being able to like make it real, not just talk about it.
Yeah, I agree with that. I think the nature of predictions is that you're going to be wrong anyway. So it's like, I think the best thing you can do is you can look at past experiences and you can try to find general principles that seem to apply across different categories. And like one of those general principles for me is that when you have a system that is very important, it's very central, such as the communication system in the case of the internet, and the payments, the world of payments and economic exchange in the case of Interledger. When you have a system like that, and there are inherent transaction costs, there's sort of a floor, like, anytime you do anything, you pay this much, then whenever you lower that floor, it's not just lowering the cost for the transactions that are currently happening or the things that are currently happening. So those get cheaper, sure. But then what happens is that there is, 100 times, 1,000 times more transactions that weren't happening because it just wasn't worth it for those use cases. And so with the internet, it's like the amount of data being transmitted has gone up millions of times. I don't know how many orders of magnitude, but many orders of magnitude. And then in the case of trading, for example, when we went from, people calling their broker on the phone to, automated algorithmic trading, the amount of trades went up by orders of magnitude. And so you can sort of expect that something similar might happen with something like Interledger. And then once you have that, then you kind of work backwards and you say like, okay, well, clearly it's not going to be a person swiping a credit card for each one of those 10,000 more transactions, because then you would be spending your entire day just swiping your card over and over. So that's clearly not what it would be, right? So it'd have to be something more automated. So maybe you have like, different systems and protocols where like your devices are making payments to each other, like you're traveling and you need internet access and you don't have any relationship with a local provider, but your phone has some money. And so it just goes out and buys an internet connection from somebody, and maybe not even a long running subscription, just like as long as you need it, while you need it, it just pays a little bit. Things of that nature might be unlocked. I think one thing that, while being a buzzword right now, I think is very relevant here is sort of AI and computers having more dynamic things that they can do, right? Like previously you had some of these very rigid algorithms where like some programmer would go and build things in a certain way, and then the computer would execute it like that. But that is really opening up with a lot more possibility today. And so I could see a lot of payments being made by some kind of AI type actors. Like I don't really like the term AI because it's for reasons that like it's not really artificial. It's really just a different kind of intelligence. But I like the idea that like we would have this vibrant marketplace of computers paying each other. That's something I think would happen. There was actually a tweet recently by, I think it's Andrej Karpathy, who's a well-known person in the AI space, that a lot of people sent me because it was something to the effect of like, if you could lower the transaction costs, then the volume would explode, he's pointing to that exact same principle.
Well, thank you both for taking a stab at those very deep questions. What kind of other deep discussions are you looking forward to at the summit that is happening end of October?
Yeah, just wait till I start telling you about like liquidity management and stuff like that. It'll be a deep discussion, trust me. There's one more thing I'm looking forward to talking about is ILDCP. I think it's one of the protocols that's gotten the least amount of love relative to what it could be. Just to explain, so ILDCP is the Interledger Dynamic Configuration Protocol. What it's used for is if you're connecting, like you spin up some Interledger enabled software, then you say, here's your Interledger connection. It would be nice if you didn't have to also tell it like, and you should use this currency, and this is the amount of units per currency that are expressed, and this is your address, and a bunch of other things. If it could just detect all of that automatically. And so that's what ILDCP is meant for. Right now, it really does only information about the currency and your address, but there's a lot of other stuff that it could communicate. One of the things I ran into recently was the maximum size that an Interledger packet could be. That could be something that ILDCP tells you. It could be like, what is the nature of the relationship between you and the person you're connected to? Are they sort of your provider? Are they an equal peer? Are they a client? So you can sort of figure that out. So there's a lot of stuff like that I think could make Interledger a lot more frictionless to use and set up, and kind of, make everything kind of feel a bit more automatic and magical if we implemented all of that.
Fun story, ILDCP was actually deprecated by mistake for a little while, and then we revived it. So in the GitHub repo, it was gone.
I think that proves my point about like ILDCP has not received the love that it deserves. It is such an essential protocol and has so much potential.
Yes, and I'm very much looking forward to talking about LDCP and all the other protocols at the summit and the hackathon the week before, and then there's a week in between, so we get a lot of time to talk about all those things. But I also want to thank you already for talking to me today. This was so much fun. I learned a lot. I'm very much looking forward to seeing you soon.
What, are we wrapping up already? Okay, well, it was a lot of fun. Thank you, Sabine. Thank you for hosting.
Bye-bye.
Hey, it's Aisha again. We wanted to remind you that we are nearing the Interledger Summit. Join the open payments movement, where a global community of changemakers is reimagining the future of digital financial systems. Our official summit will kick off on October 26th with a dynamic schedule of inspiring speakers and engaging sessions. We also welcome you to our pre-summit activities, including a community open house on October 25th.
If you're unable to attend the summit but you would still love to follow our sessions, then you can find the Interledger Summit's live stream and previous recordings on the Interledger Foundation's YouTube channel. For more information, follow the link in the episode description. And as always, thank you for tuning in to another episode of the Future Money Podcast. We'd love for you to like and subscribe wherever you listen to your pods.